let's balance a redox reaction. Here's a redox reaction here, and when you balance redox reactions, you should follow a series of steps, and they're outlined in many textbooks. I'll go through them right now. So this redox reaction, the first step is to break the redox reaction into two half cells. So you have to recognize what's being oxidized and what's being reduced. So if you look carefully at this, you'll find that there's the chromate and chromium, and the alcohol and the aldehyde, and there's an oxidation occurring and a reduction occurring. Well, let's go through and see which is which. So here's chromium. In the dichromate, oxidation number of oxygen is -2, pretty much universally. So we can use that and this charge state to determine the oxidation number of chromium. And that turns out to be +6. And the oxidation number here is obviously +3. So chromium is being reduced. Its oxidation number is reduced. So hopefully that means an oxidation is occurring over here. And if we analyze this using the same kind of rules, oxygen is always -2, hydrogen is always +1. Then we can look at this, and you might also need to draw a Lewis dot structure to figure out which carbon is being oxidized or reduced. And here I've highlighted it in green. But the oxidation number of this carbon goes from +1 to +2. An increase in oxidation number, that's an oxidation. So I have a reduction and an oxidation, and I can continue to balance them now as half cells. So the next step, balance the elements in your two skeletal half cells. Well, in the reduction, the 2 chromium here, only 1 there, so I need a 2. And in fact, I'm just going to go through and apply the steps to the chromate first and then come back and do it for the alcohol and the aldehyde. So the next step would be to balance the oxygens by adding water. So for this reaction, I have 7 oxygens over here, so I should add 7 water molecules over here to get the oxygens to balance. Now I have to balance the hydrogens by adding H+. And I just added 14 hydrogens over here, so I'm going to add 14 H+'s over here. The next step is to balance the charge with electrons. So I've got quite a charge building up here, and if I add up all my charges, I find that I need to add an extra 6 electrons to get the charge on this side to be equal to the charge on this side. So I have a charge of 14 pluses, 2 minuses, that brings it down to 12, and another 6 minuses, it brings it down to 6. So 6 pluses here and 2 times +3, 6 pluses there. Now let's do the same thing for the alcohol to aldehyde. Balance the elements. All the elements are balanced here, so nothing required there. Balance the oxygen with water. I have 1 oxygen on both sides, so nothing required there. Balance the hydrogens by adding H+. In this case, I do need a hydrogen, so we'll add 2 hydrogens to this side so that we have 1, 2, 3, 4, 5, 6 hydrogens on this side, and 1, 2, 3, 4, 5, 6 hydrogens on this side. Now balance out that charge. I just added 2 pluses here. This side is neutral, so 2 pluses plus 2 negative electrons, that'll make both sides 0 charge. Now I can bring my 2 half reactions, now that they're balanced, back together and balance the electrons in both half cells. So this half cell, I noticed 2 electrons, and I noticed that's an oxidation. 6 electrons here, and that's a reduction. That's good. That's what I thought was happening, and my procedure has confirmed that. So let's balance them out. Let's multiply this top reaction through by 3 to get the electrons to cancel, and then add them together. So I've checked to make sure I have a reduction and an oxidation, and I've balanced my electrons. I'll add the 2 reactions together with my factor of 3. Now I can cancel the electrons, and some of these hydrogens are going to cancel and leave me 8 hydrogens over here. So I'll have 8 hydrogens, 3 ethanol, and the dichromate going to 3 of the aldehyde, 2 chromium ions, and 7 water molecules. Now I should go back through and double check that indeed it is balanced. And you can see now, if you count up all the hydrogens, all the oxygens, all the chromiums and carbons on this side, they exactly match up with that side. So going through that series of relatively simple elementary steps, I balance a chemical reaction that would have been quite difficult to balance starting from first principles. That's how we balance redox reactions.